Did you know there's an insect that doesn't flee from fire, but instead races straight into it? While every other animal panics and runs away, this particular insect treats flames like a signal flare. The reason? Unless a tree burns, it cannot lay its eggs. It waits for destruction and then rushes in, guided by a mechanism eerily similar to missile technology. But which insect is it? And why does it follow such unusual behavior? And how did researchers first discover such a paradoxical creature? To answer all these questions, we have to go back to the 19th century. In the 1920s, a baffling scene played out in forests across North America. Scientists observed beetles, hundreds at a time, appearing rapidly and mysteriously around trees charred by recent fires. Even more strangely, these beetles completely ignored lush, healthy trees mere meters away. Instead, they exclusively swarmed regions freshly scorched by lightning strikes or wildfires, sometimes arriving within hours from places dozens of miles distant. Researchers were perplexed. How could such small insects track fires so quickly from such incredible distances? Initial theories suggested familiar sensory cues. Some proposed that smoke or distinctive chemical odors guided the beetles. Others assumed heat itself drew them in. Yet these explanations proved insufficient. Beetles appeared impossibly fast, and often from areas far beyond the range of ordinary insect senses. But how is this insect able to detect the fire? But what kind of creature evolves to seek out death just to give birth? The extraordinary insect known as the Jewel Beetle belongs to the genus Melanophila. The Jewel Beetle gets its name from its stunning appearance. Its shell shines with an iridescent glow, showcasing colors that shift with the light, much like polished metal. Some species exhibit deep greens, fiery bronzes, or even subtle purples, while others may be less vibrant but still reflect light in remarkable ways. This captivating beauty does not come from pigments, but rather from the unique structure of their wings, which have microscopic surfaces that bend light to create color. Typically, jewel beetles are oval-shaped and have an armor-like appearance. They're often seen resting motionless on bark, blending perfectly into the forest's natural shimmer. With over 15,000 species in the Buprestidae family, they've adapted to nearly every continent except Antarctica. But what makes Melanophila truly extraordinary isn't what it looks like, it's what it knows, because somehow this beetle always shows up after fire. It's not instinct or luck, it's a hidden weapon buried deep inside its body. Hidden beneath the jewel beetle's glittering metallic armor lies a superpower called infrared vision. This tiny, fluid-filled pits embedded within its thorax act like microscopic thermal cameras, completely invisible to our eyes, yet astonishingly precise. Each of these pits contains about 70 microscopic sensory receptors, finely tuned to detect minute heat waves radiating from distant wildfires or lightning strikes. This sensory system functions much like a biological missile lock mechanism, instantly focusing on the faintest thermal signatures from fires burning over 60 kilometers away. Researchers, stunned by this evolutionary masterpiece, discovered the beetle's infrared detectors closely resemble modern missile guidance technology used by military forces. These tiny creatures literally had military-grade heat detection capabilities millions of years before humans built their first thermal sensors. What makes this adaptation even more astonishing is its simplicity. Unlike man-made infrared equipment, which requires elaborate cooling and complex machinery, the beetle's infrared sensors effortlessly operate at ordinary temperatures, instantly converting heat signals into nerve impulses. German scientists studying this extraordinary sensory ability even developed biomimetic sensors inspired directly by the beetle, demonstrating how nature's ancient innovations still surpass modern human inventions. But most remarkable is how this incredible infrared vision reshapes behavior. While every other creature desperately flees from smoke and flames, jewel beetles utilize their heat-sensitive organs to deliberately track down wildfires. Instead of avoiding disaster, they navigate toward it with perfect, calculated precision, exploiting devastation as an opportunity. Imagine the visual wonder. Tiny beetles soaring purposefully across miles of landscape, guided invisibly by trails of thermal radiation. Each creature an organic heat-seeking missile, racing confidently toward fires hidden beyond the human horizon. It's a testament to evolution's astounding creativity, granting an insect capabilities beyond human technology. But why would it chase fire? Why risk flying straight into an inferno rather than escaping from it? For Melanophila beetles, fire is not danger. It's the gateway to life itself. These beetles can only reproduce in freshly burned trees. Female beetles instinctively seek out fire-scorched wood to deposit their eggs, relying entirely on flames to prepare a perfect nursery. In healthy forests, trees defend themselves fiercely with thick bark, toxic chemicals, and sticky resins, preventing insects from burrowing inside. But fire changes everything. Intense heat strips away these protective defenses, neutralizing sap and toxins that would otherwise trap or kill beetle larvae. Essentially, wildfire transforms impenetrable trees into helpless, ideal hosts. Moreover, fires eliminate competition, wiping out rival insects and driving away predators. By arriving swiftly after a blaze, Melanophila beetles guarantee their offspring an environment nearly free of threats. Charred forests become sanctuaries of survival. Once beneath the scorched bark, the eggs quickly hatch into larvae. These larvae effortlessly tunnel through the softened wood, feeding freely without resistance because the tree, dead from flames, can no longer fight back. One researcher described it simply: there are hardly any predators left in a freshly burned forest. Additionally, fire-induced decay encourages fungi and microorganisms that rapidly soften wood fibers, creating a nutritious, easily digestible meal for the growing larvae. Thus, devastation translates into abundance, making scorched wood a safe, rich haven. Remarkably, Melanophila beetles do not even wait for flames to subside before claiming their territory. Often, adults gather amid smoke and heat, while the forest still smolders, mating swiftly to produce the next generation. Some have been observed laying eggs on trunks still hot enough to smoke, so driven by urgency to secure their offspring's future. Without fire, Melanophila beetles have no chance of survival. Their extreme reliance on such destruction underscores a profound paradox. Their very existence depends entirely on chaos, making them true pyrophilous, fire-loving insects uniquely adapted to thrive amidst ruin. So what happens once the flame dies? Once flames die down, Melanophila beetles become vital to forest renewal, emerging as nature's frontline recovery crew. Among the first colonizers of burnt landscapes, their larvae quickly burrow into charred trees, accelerating decomposition and nutrient cycling. Where others see ruin, it sees renewal. What looks like the end is just where this beetle begins. But with power that precise, what happens when it backfires? Melanophila beetles' extraordinary heat-seeking senses aren't foolproof because they're drawn primarily by infrared heat and smoke signals. These beetles sometimes misinterpret human-made sources as natural wildfires, with amusing and bizarre consequences. In Australia, a closely related species, Merimna atrata, earned the nickname barbecue beetle because of its enthusiastic swarming around backyard grills and bonfires. Similarly, in California during the 1950s, gatherings around barbecues smoking meats attracted unexpected visitors. Swarms of Melanophila beetles landing on guests, confused and nibbling at people's necks and shoulders. The humans, bewildered and irritated, unknowingly sent out false fire alarms with their dinners, unintentionally luring these fire-seeking insects. Industrial environments can also trigger these mistaken invasions. Sawmills, brick kilns, and cement plants regularly emit heat and smoke, closely mimicking wildfires. A striking example occurred at a Southern California cement plant, where thousands of Melanophila beetles descended upon steaming clinker piles and smokestacks, prompting workers to nickname them stack bugs. Attracted to surfaces exceeding 50 degrees Celsius, the beetles frantically scurried along conveyor belts and hot machinery, sometimes crawling underneath workers' clothing and delivering sharp, pinching bites. Apparently, the beetles mistook the warm human bodies for cooling logs post-fire. Even stranger incidents unfolded at UC Berkeley's Memorial Stadium in the 1940s. During football games, swarms of small black beetles repeatedly landed on spectators, biting and creating confusion. The culprit was cigarette smoke from the crowds, a haze of heat and chemicals resembling a distant forest fire. Without charred wood nearby, the beetles settled on people instead, triggering panic and bewilderment. Today, large dark surfaces heated by sunlight, such as solar panels, metal roofs, and parked cars, still occasionally fool these insects, proving the beetle's senses remarkably precise yet vulnerable to deception. This beetle proves nature's strangest stories hide within ordinary forests, creatures whose lives depend on the very disasters humans desperately try to avoid. Its infrared vision and fire-loving behavior blur the lines between survival and destruction, raising powerful questions. Are our interventions in nature always helpful, or could protecting forests accidentally threaten species dependent on chaos? If you found this creature's paradox fascinating, share this incredible story, because nature's secrets run deeper than we imagine. And who knows, next time you spot smoke rising, you might remember the beetle whose life literally starts where everything else ends. Thanks for watching the video. Press the subscribe button and the bell icon for regular updates.